Thanks very much, Ivan. And our next speaker is going to be, for those of you, let me look around the room. Any people who look like they're over about 60, late 50s? So this Ian Butterworth is going to come up and talk about, well, this will be of interest to you, a non-invasive hydration sensor for elderly care. Ian.
Hi everyone, my name's Ian and I'm working on a hydration sensor to try and keep older adults better hydrated. So we all know hydration and dehydration, but the thing is that it's different for older adults. As we age, we lose our sense of thirst. It diminishes with age, and it can mean that we develop a slow chronic dehydration that can result in moderate to severe dehydration. Let's say we lose 4 to 5% of our total body water over a matter of a week. It can cause things like falls, urinary tract infections, and many other issues that can result in hospitalization. It's rarely the primary diagnosis in a hospitalization, but it's very commonly the second. Now, if we look in the residential care facilities, where there are 7 million people in the US. So that's 7 million times a day or more where residential care workers try to figure out the hydration status of an older adult. And the problem is that there's really no decent way to do it. There's no decent way to detect a small change in hydration status. Ins and outs don't work because ins are very difficult to do precisely, and outs are pretty much completely impractical. Symptomatic observation doesn't work because it presents too late once the dehydration is set in and risk has increased. Now, the hydration monitoring market is quite active. There's a few companies in the works. Nobody has been shown to remove the drawbacks that get you to solving the unmet need of detecting a small change in hydration status over a course of days in a practical way. So we've developed a sensor that does a measurement of subepidermal water content. We use gigahertz range electromagnetic fields to measure that space, and we are operating in a frequency regime that's higher than other electrical methods, which allows us to move away from conductivity and sensitivity to salt. So we're very sensitive to water specifically, and we can control our penetration depth. We also have a novel approach to just measuring the extravascular space, so we're not affected by vasodilation. And one thing that really enables our device to be truly impactful is the miniaturization of electronics in this gigahertz range, which makes our device a potentially very small, wearable, or portable device. So our evidence. Thanks to Deshpande, we've been collecting controlled studies on adults, healthy adults, where we've shown that our measurements correlate very well with a mild dehydration and then a rehydration back to baseline. And we've also been able to do real-world studies in uncontrolled settings where we've studied 22 older adults in a study over 7 weeks, where we showed that the uncontrolled standard deviation across our measurements is in the order of what we might expect our standard deviation in hydration status within a population that doesn't have severe events happening. But one thing that you'll notice is that the range of baselines that we're measuring across these people is variable. So the strength of this technology is in a relative tracking of hydration status over time to inform how to rehydrate. We've also been doing tissue models. We've shown excellent linearity and sensitivity to water content in tissue models, and our sensitivity to water vastly exceeds our sensitivity to any of the confounding factors that we've identified so far. Now, the market size. There are 67,000 US facilities and service centers based around the 7 million elderly people, older adults that receive care. So it's a very sizable market. There's a variety of ways to roll out and a variety of different service models. And hydration is remaining to be and growing as an issue on the minds of the healthcare industry. There's many studies, one study indicating that the cost of preventable dehydration is as much as 1.3 billion, where dehydration is the primary diagnosis. So it's actually a much bigger issue because of its underlying nature. And also there are many policies and regulations opening up to try and identify prevention measures. We've also seen firsthand, I mentioned our 7-week study, our 56-person survey, and our 23 in-depth interviews with people within these facilities has really helped us identify that this is a really big issue that people really need a solution for. And looking forward, we're looking to raise money to extend our human studies, but we're also looking for partners for developing of an embodiment for our sensor, and we're recruiting for study participants. I actually put a post out in the conference app, so if you're interested in being part of our healthy adult studies, or you know somebody that is, please pass on the link and fill out the form, and we'll let you know when we have studies open up. Thank you very much.